Okay, so there should be the two curves. If we think about that idea of your average revenue, what is another name for average revenue as to what we would normally refer to that curve as being? What curve represents a price and quantity that people are willing and able to? So in this one, this is a demand curve, yeah? So another word for a demand curve is an average revenue curve. So if there are two people prepared to pay £3, there are four people prepared to pay £1, well, that demand curve is just representing, on average, what would each of them be paying. So average revenue could also be used with the word a demand curve. Okay? If we look at the other questions on that sheet then, where or what quantity did we see that total revenue was maximised? At what point? So how many units was the highest level of revenue? So 2 units, total revenue was 18. Was that the highest? 5 and 6. Yes, so at both those points, the total revenue was 30. Now this is where, in year 12, when we talked about things like price elasticity of demand, we touched upon it and we drew like an inelastic curve and an elastic curve. Now what I assumed there was that the elasticity of that was true for like that whole curve was completely inelastic, that whole curve was elastic. Now that is not necessarily going to be true if you think about what that means in reality. So I said to you, a Freddo has what type of elasticity? Elastic. Sure?
Inelastic.
Let's pick which one we're going for.
Inelastic.
We're going for Matt? Inelastic. What was the reason?
Because they keep upping the price and people still buy it.
Okay, and why are people still prepared to pay for it?
It's still fairly cheap.
Right, perfect. So it's a low percentage of your income. So you put it up by 10p, you put it to 20p, that's a 100% increase in price, but demand will still fall, but it will be less than proportional. But what happens if you then put it up to 40p? Do you think the same amount of less people will buy? Because that's another 100% increase. Do you think more and more people? So then let's put it up to 80p, because that's another 100% increase. As soon as I'm hitting 80p, what's happening with that Freddo?
It's almost the same price as like a normal bar.
Right, so once I start to get to those price points, the product might actually likely to become what rather than inelastic? Elastic, because it's becoming more expensive, it's becoming a higher percentage of my income. Okay? What that means, or what this theory is about to tell us, is that a demand curve actually has different levels of elasticity attached to it. Because we've often drawn a demand curve as being straight. Why do you think we've done that in economics? Say that again? Simplify it. You bring a ruler to school, draw a demand curve, I'm done. An actual demand curve is actually going to be a curve, hence why it's called a demand curve, because at certain price points, so if you think about like a subway, a foot-long subway, at some point, right, if they hit £1 each, if that then drops to 50p, realistically, would you like still be buying more of them? Or once they're at £1, I probably can't eat any more foot-long subs because you've hit a price point where I will have it for breakfast, lunch and dinner. I don't want to eat a full foot of sub. I'm already half my body length. So at that point, at that low price point, we're quite inelastic. I can't consume any more of it. Okay? So at that bit, I have quite an inelastic bit. But then there was that point where I suddenly went, well, you know what, at £6 a sub, I'll treat myself at the weekend. But at £3, again, I'll go daily. So like, there's that big variation. And that's what we need to start demonstrating here. Okay, so although a demand curve looks straight, it will have various elasticities going along it. So if you imagine here, with regards to before we hit that maximum point, what's happening to that total revenue as the price is falling? What's the total revenue doing? Going up. So what type of elasticity would that be at the start? Elastic. Yeah? So we've got a change in price, but we've got a more than proportional increase in demand, so total revenue is rising, and then total revenue hits a peak. Where can we see, particularly in that diagram, or where do you think there's a mathematical observation that we've reached the highest point of our total revenue? What curve is telling me what's changing with regards to total revenue? Excellent, marginal revenue. And that marginal revenue curve, at some point, so remember it's the additional revenue from each unit. Because it's the additional revenue, I don't lose the revenue before, so total revenue is getting higher and higher. So if we have a look, marginal revenue, so I get £10 from the first unit, I get an additional 8. I don't lose the £10, I've got that banked, I get an additional 8 on top. Then I get an additional 6 for the third unit, I've not lost the 18 because I've gone to 24, and then get an additional 4, I get an additional 2, then it doesn't change. Right, what does that mean then if marginal revenue is starting to actually become negative?
Making a loss.
Not necessarily making a loss yet, okay, but my revenue is, because if it's -2, it still means that I've got revenue of 28, but that is just 2 less than what it was before. So what's happening to my overall revenue if marginal revenue is becoming negative? It's decreasing, it's getting smaller. So if I had an objective of wanting to maximise my revenue, graphically, where should I do that on the graph? Where marginal revenue does what?
Intersects.
Right, perfect. Where it intersects. As long as you've got marginal revenue intersecting that x-axis, that is what we call revenue maximisation. Because below that, if that's a negative number, your total revenue will begin to fall. It doesn't necessarily mean you're making a loss. It doesn't, and we can't tell about profits, because if we were to do profits, what other information do I need to calculate profit? Cost. I don't have that information. Like, you could be making losses here. If it costs you £1 million to make any of this, all of it's a loss. So in that sense, it's just here is revenue max. And that's something I'm going to need for you to remember. When marginal revenue equals 0, you are at revenue max. Right, as we then continue to drop the price, what starts to happen to my total revenue figure? What's happening to that number? Decreasing. So if you're lowering price and total revenue is falling, my demand curve has now actually become what? Inelastic, yeah? This is like the subway point where, yes, you might get a couple more people buying it, but it is less than proportional. Here it was more than proportional, here it was less than proportional, here was revenue max. And that's the concept, okay? Demand curves, or the PED on the demand curve will differ as you move along it. There'll be a point where revenue max happens, and a business, imagine if you want to calculate this. So if you think about a company like, well, any company that has an objective, say for example, of maximising their revenue, like their market share, if that's how we calculate it, well the question there is, well, where is that point? Well, as an economist, if you give me your PED estimates and you give me these numbers here, I'll tell you where that point is, and then you can operate at that point. Because we talk a lot about the hypothetical nature of economics, but if you've actually got the numbers, I will tell you all of those exact positions, which ensures that you create the best pricing strategy as part of it. Okay, because obviously if you were this business, you would either charge £6 or £5 as part of that process. Okay, and in a later lesson we'll talk about why it will be that lower number. Okay?